Good morning. So today's topic is Cyclo Converter. So basically, Cyclo Converter is a device which convert one AC into another AC with change in frequency. Okay. So whether we can convert a variable frequency into a one frequency, or we can also convert one frequency into variable frequency as per our requirement. For example, if we see the application, so there is a one very important application that is in three-phase induction motor, that is a V by F method, variable for voltage and variable frequency method. So in that application, we basically need a cyclo converting circuit where one frequency has to be converted into many frequencies as per our requirement. It doesn't mean that at a time, it means that at a time we will have a one frequency, but we can convert one particular input frequency into variable in output frequency as per our requirement. For an example, if you want 60 Hz frequency at a particular time and we have a supply of 50 Hz frequency, so we can convert a 50 Hz frequency into 60 Hz frequency. But at another time, if there is a requirement of a 65 Hz frequency, then we can also convert this 50 Hz frequency, that is the input frequency of the input supply, into a 50 Hz output frequency. Okay. So in a speed control of a high power AC drives, we basically need a cyclo converting circuit. And on the other hand, in the spacecraft, or you can say in the ship board, where we have a different types of frequency in the output, but for running a particular application we need one frequency. So we will need that type of cyclo converting circuit where we will convert the AC supply into a one particular frequency, whatever with our input frequency. So for controlling the frequency of the input, we need a cyclo converting circuit there. Okay. And on the other hand, we have a application in the induction heating and static wear compensation, which is one of the best method of reactive power compensation technique. So these are some applications of a cyclo converting circuit. Basically, we have two types of cyclo converting circuit. One is a step up cyclo converting circuit, and another one is the step down cyclo converting circuit. So in the step up cyclo converting circuit, we need a frequency, output frequency higher than input frequency, and in the step down cyclo converter we need an output frequency which is lower than the input frequency. Okay, so this is the main circuit of a cyclo converting circuit. Is the main main circuit of a cyclo converting circuit. It is basically a midpoint cyclo converting circuit. There is also a bridge type cyclo converting circuit, but due to the lack of time we will not discuss that. We will discuss only the midpoint cyclo converting circuit here. So basically this is the input. So we can write here as a input, that is Vm sin omega t, as we know that it is a single phase cyclo converter. We do have a three-phase cyclo converter also. Okay, so here we see that now this circuit can be used both as a step up cyclo converter and step down cyclo converter. So same circuit can be used for a step up cyclo converter and step down cyclo converter, but the difference will be of switching. Okay, different switches. These are all 4 switches. Thyristor here it is used as a switches. So these 4 switches, automatic switches, will be operated at different time, and because of this, the same circuit can behave as a step up cyclo converter, and the same circuit can also behave as a step down cyclo converter. So step up and step down both. So So here we have a 4 automatic switch. This is a transformer. Okay, so basically input supply is being isolated from the output supply. Okay, electrically it is isolated, they are isolated, and we have 4 switches, automatic switch. So and depending upon different types of different ways different duration of and method of triggering, you can say that we will convert these circuit into this circuit will help in converting the input frequency into output frequency AC supply of different frequency. Okay, so these are all 4 switches, they are connected in this fashion. We will later on see why this type of arrangement are necessary, and this is the load where we need an AC. Okay, so here it is in AC and here it is also in AC, but at this AC we have a AC of different frequency as compared to this AC. So input is also AC and output is also AC, but here input frequency is different and here frequency is different. Okay, so this is the main power circuit. We all know that this is a power circuit, and there is a control circuit connected in here in all the 4 control kit. We can say that with the help of different types of processor they are connected, microcontroller they are connected. Okay, and there will always be we all know that there will always be some protection circuit here. Okay, so let's start discussing cyclo converter. So basically in the step up cyclo converter, which we will first discuss, in the step up cyclo converter, forced commutations are used. So what do you mean by forced commutations? Forced commutation means these all 4 thyristors are forcibly commutated. Means when we need the thyristor to get turned off, we will there will be some circuit here added. There will be some circuit added here that will forcibly put this thyristor into off condition. Means there will be a circuit here that will come into existence when we need to turn off this thyristor. Okay, similarly for these 3 thyristor also. So in the forced commutation we need some circuit that will forcibly commutate the thyristor. Forcibly commutate means they will create a conditions for turning off. जो हम लोगों ने कंडीशंस पढ़ा था ऑफ होने का, पहला कंडीशन था कि हमारा जो एनोड करंट है जो थायरिस्टर से फ्लो कर रहा है करंट, वो होल्डिंग पॉइंट से नीचे जाना चाहिए. दूसरा जो कंडीशन था कि इसमें रिवर्स वोल्टेज अप्लाई होना चाहिए फॉर द रिक्वायर्ड टाइम, दैट इज नोन एज टर्न ऑफ टाइम. इतने देर के लिए इसमें हमारा एनोड करंट होल्डिंग पॉइंट से अगर नीचे चला जाएगा तब ये क्या होगा, ऑफ हो जाएगा. सो ये कंडीशंस हमें यहाँ प्रोवाइड करने होंगे. ठीक है, जब हम इस पर्टिकुलर थायरिस्टर को ऑफ करना चाहेंगे तब. सो फोर्स्ड कम्यूटेशन में एक सर्किट यहाँ लगा रहेगा दैट विल फोर्सली कम्यूटेट द थायरिस्टर by applying the necessary condition for getting turn off. Okay, so these forced commutations ये हमारा स्टेप अप साइक्लो कन्वर्टर में यूज होगा. और स्टेप डाउन में मेरा नेचुरल commutations means there will be no circuit added here due to the nature of the supply. Current across the thyristor will automatically come down to holding point and a reverse voltage will be applied for at least time, that is turn off time. Okay, so in the forced commutation we do not need any extra circuit, but in the forced commutation we need some circuit here that will forcibly commutate the thyristor when required. So we will see these two circuits, these two mechanisms for this circuit, same circuit in coming sections. Okay. So this I have drawn here. Okay, so this I have drawn here. So we will take two conditions. First we will boost the frequency by 6 times, and in the second case we will boost the frequency by 4 times. Okay, so first consider the case here. So this is the AC supply. Okay, one cycle, complete cycle input. So for one complete cycle, if we need 6 times boosting of the input frequency, okay, Fs is the input frequency, now F0 is the output frequency. So Fs you can write here Fin instead of Fs, right here Fin instead of Fin, because I have written here Fin. So for boosting the 6 time frequency here, and we will boost the 4 times frequency here. Okay, now this is the AC supply. This is the one complete cycle. So in this one complete cycle here we will create 6 AC cycles, complete AC cycles of output. So how we will do this? Let's see. Okay, so for simplicity, we will consider here as a pure resistive load. Okay, so in the practical load, we all know that is not a pure resistive. So slightly there will be some difference but for understanding this working of a cyclo converter here, we will consider only as a purely resistive circuit where there is no voltage difference between, there is no phase difference between output voltage and output current. Okay, so first what we will do, first in the interval 0 to pi, so when the input supply is from 0 to pi, so in the interval 0 to pi, what is basically happening here happening is that this is plus, this is minus, this is plus, this will be minus, this will be plus, and this will be minus. So see here, E point is both plus and minus. So it is minus with respect to this and it is plus with respect to this, means E is at higher potential with respect to D, but it is at lower potential with respect to F. Now when in the interval 0 to pi, which two thyristor are capable of conducting? Since it is plus and it is minus, so when it is plus, only P1 is capable of conducting, and here N2 is capable of conducting, but it will not conduct until unless we supply the gate pulse. Okay, so for understanding, I have drawn here in this way. Okay, and in this curve we will draw the waveform. Okay, so when it is plus and when it is minus, when it is plus and when it is minus, plus minus plus minus, P1 and N2 is capable of conducting. So for yes, P1 and N2 is capable of conducting. So here I will do what we need first, the in positive cycle. So let's suppose the direction of current from A to E is considered as a positive. So for that we need to trigger this P1. So suppose, okay, see, N2 can also be triggered, but if you trigger the N2, the current will flow from E to A. Okay, so I have here considered taken A to E as positive. So you can also take E to A as a positive. In that case you will trigger N2. Okay, there is no problem with that. But for understanding, we are taking assumption here that when the current is flowing from A to E, the current is positive, and when it is flowing from E to A, it is taken as negative. So for A to E, P1 will be triggered. Now P1 will be triggered at this point. Okay, so at this point P1 is triggered. Now when P1 is triggered, output voltage will be equal to supply. So now it is taken as 1:2 ratio. So it is Vs. So it will be Vs. It will be Vs. Now when it is on, this voltage will be equal to this voltage. That's why we have drawn here as this. Okay. Now at this point, what will happen? We will forcefully commute this P1. P1 को हम बंद कर देंगे कंडीशन अप्लाई करके. इसलिए इसे बंद करना है क्योंकि अब मुझे नेगेटिव साइकिल में करंट, वोल्टेज या करंट चाहिए. सो नेगेटिव में लाने के लिए we will forcefully commute the P1 and at the same time we will trigger N2. Now as soon as we trigger N2, the current will start from E to A. Okay, then one question might be here, might arise here, that if the current is flowing from A to E, then how can suddenly current flow from E to A? That's why this is okay. If you have this queries, then it's okay. But I have in the starting assumed that there is no voltage difference between output and current. That means current, load is a purely resistive. That's why in a pure resistive, current can change suddenly. Okay, that's why we will forcefully commute P1 and at the same time we will turn on the N2, which is capable of conducting. N2 is capable of conducting. Okay, so here I have forcefully commuted P1. So this is P1. Now when we will forcefully commute P1 and at the same time we will trigger N2, current will flow from E to A in this direction. So output voltage or current will be here. Okay, so this is N2. Okay. Now again at this point we will forcefully commute N2 and again we will turn on P1. Now P1 is again capable of conducting. It is still in first half cycle. Input is still in first half cycle, and in that duration we have turned off the P1 thyristor one time and again we have triggered P1 for the second time. Now this can happen because we all know that the thyristor has a turn on and turn off time in the range of microseconds. Okay, we all earlier have discussed in the switching characteristic. So this is for if it is a 50 Hz cycle, so this time is 1/100 seconds. So this 1/100 second is a very large time. So in that case it can switch on and switch off simultaneously in a number of times. Okay, so we have turned off the P1 here and again we have triggered the N2 here and again we have turned on forcefully commutated the thyristor number N2 at this point, and we will again turn on P1. So P1 is capable of conducting, so we will again turn on the P1 thyristor. Okay, so when the P1 will trigger, again current which was flowing earlier from E to A will suddenly flow from A to E. So in this direction. Okay, so again P1. Now again at this point we will forcefully commute the P1 thyristor and we will trigger the N2 thyristor at this point the same way. Okay, again N2 is capable of conducting. So in the interval 0 to pi, P1 and N2 are capable of triggering So they will be triggered number of times depending upon the how much frequency we have to boost up. Okay, increase. So these two thyristor P1 and N2 can be triggered number of times. They can be triggered number of times and they can be forcefully commutated number of times, because on and off time has a range of microseconds in terms if the switch is taken as a SCR. So this can be done easily. So again we need a 6 time frequency. So that means for 1/2 cycle we need 3 times full cycle. Okay, if we want to boost up the 6 time frequency, so in that case what will we will do? For a half input cycle we must have a 3 complete cycle, then only in a complete cycle we will have a 6 cycles na. So we will again forcefully commutate N2 here, and we will again, this is one complete cycle, second cycle, again we will P1, and again P1 will be forcefully commutated, and again N2 will be turned on. Okay, so this is a one complete cycle, this is a second cycle, and this is the third cycle. So this will be done by triggering P1 and P2 number of times, and again forcefully commutating P1 and P1 and N2 number of times. Okay, number of times depending on the frequency, how much frequency we have to boost. Here we have to boost the 6 times of frequency. That's why we have turned on the P1 and N2 3 times in a half cycle. Okay, so here we have for a half cycle of input we have a 3 complete cycle of output. Again at this point, now at this point what is basically happening? Input supply is getting reversed. Now this has become negative. This has become negative, this has become positive. So this is plus, minus, this is plus, this is minus, and this is plus. Now when this happens, that is in the interval pi to 2 pi of the input, what will happen? See here, point is at higher potential with respect to F, and it is at lower potential with respect to D. Now which two thyristor is now capable of conducting? That is N1 and P2. Now see which thyristor will be turned on first. Now we always need a first